Hi guys, my name is Seshan. I'm currently studying in 12th grade and I'm preparing for NEET. As few students are not accessible to online classes, I thought of to teach to 11th grade students in which I'm teaching the subject physics. So in that subject physics, I'm teaching you the chapter motion in a straight line, which is the third chapter. Okay. So as you see the heading of this chapter, motion in a straight line, what do you infer? So as you see this chapter name, motion in a straight line, motion, what do you mean by motion? Motion is any object which changes its position with reference to time and reference frame is called motion. So the motion which is happening in a straight line is called motion in a straight line. So this chapter motion in a straight line and the next, that is fourth chapter motion in a plane, comes under the branch of physics called kinematics. So what is kinematics? Kinematics is the branch of physics which deals with the study of motion without actually knowing the cause of it. Okay? So the next thing which we have to learn is what is motion and rest. As I have already said you, what is motion? Motion is any object which changes its position with respect to time and a reference frame is called motion. What is rest then? Rest is complete opposite to that. That is, any object which doesn't change its position with respect to time and reference frame is called rest. So I've been talking about reference frame, right? What is reference frame then? So reference frame, this motion and rest are the two terms which cannot be defined without knowing the observer. That means these two are the relative terms. Without the observer, we cannot define these two terms. So frame of reference is observer. Okay. So as mathematics is the language of physics, we have to express everything in mathematics. So which topic in mathematics will show you the change in distance, etc. So which is that topic? Yeah, coordinate system. So we have chosen coordinate system to represent motion and rest. So the coordinate system comprises of x, y and z axis. So any motion in which the dimension, when there is a change in the one dimension, we call it as motion in a straight line. When it is changing in the two dimension, we call it as motion in two dimension or motion in a plane. When it is changing in three axis, that is three dimension, we call it motion in three dimension or motion in space. Okay. The next thing which we have to learn is parameters of motion. So the five parameters of motion are distance, displacement, speed, velocity and acceleration. So let us study what is distance and displacement first. Okay. So distance. Distance is denoted by the letter S, small s. So distance is the length of the path covered by an object. Suppose you consider 2 points, initial point and final point. So distance may be this one or maybe this one or etc. So distance is a scalar quantity. Its SI unit is meter. Its dimensional formula is m power 0, L power 1, T power 0. Its CGS unit is centimeter. So displacement is analog of distance. Displacement is a vector quantity. That means it is the length of the shortest path between 2 points. That means you consider initial and final point. So distance is the length of the path covered by an object to cover 2 points. That means between 2 points. Okay. So distance can be anything. This is distance. But while defining displacement, you have to define as the shortest length between 2 points. This is the displacement. And displacement has a direction, in which distance doesn't have the direction. So when the point is moving from this initial point A to the final point B, it is in the direction of right side. So when it is moving, you consider this distance as displacement as 20 meters. So while saying the displacement, we say as the body has covered 20 meters in the right direction, in the east direction or otherwise. Okay. So the same will holds good for displacement as well. SI unit is meter. Dimensional formula is m power 0, L power 1, T power 0. As I said, motion and rest are relative terms. What do you mean by relative terms? You consider an observer standing there and I am walking front. So what he thinks is standing there. What he thinks is I am moving in the forward direction. So you consider that he is also moving along with me in the same direction with the same speed. See, he is moving with me along with me. Okay. So what I see is I am at rest with respect to him. So whenever you define motion and rest, you have to define with some observer. So as I said, reference frame. As mathematics is the language of physics, you take coordinate axis, right? So origin is represented as an observer. So there is no rule that observer must be in origin. It can be at anywhere in the coordinate system. But conventionally we take observer is at origin. So the next parameter, speed, velocity and acceleration, will be discussed. Let us look at key points related to distance and displacement. So distance is greater than or equal to displacement. How? Consider initial point here and final point here. So displacement is always the shortest path, while distance may be this or any other path. So if you consider this is 30 meters, by common sense this is greater than 30 meters, so that distance is greater than displacement. So how distance is equal to displacement? If you consider these 2 points, if object travels along the shortest path, now distance is equal to displacement. Fine. So let's move. Distance is either 0 or positive. If an object doesn't cover any distance, it is 0. If it covers some distance, it is positive. But displacement may be negative, 0 or positive. 0 same as distance, positive same as distance, but negative because displacement is a vector quantity. By sign convention, if you take a right direction as positive and left direction as negative, if body covers in the right direction, it will be positive. If body covers distance or path in the left direction, it will be negative. So we cannot say distance as negative because it is a scalar quantity which doesn't have direction. It just have magnitude. So displacement can be negative also by the sign conventions. There are infinite distance, but there is only a single displacement possible between 2 points. You consider this situation in which displacement is only this path, but distance is this, or even this, or etc. Okay. So distance depends on path, while displacement is independent of path. That means it only depends on initial and final positions. Okay. The displacement can be known only using initial and final point. There is no need of the path. So the problems will be discussed. Let us look at problems. The first problem. A particle starts from the origin, goes along x-axis to point 20 meter, 0 in the coordinate plane, and then returns along the same line to the point minus 20 meter, 0. So while solving any problem in the chapter motion in a straight line, you have to imagine the situation. That means you have to write on the situation. So first we'll write on the situation. Particle starts from the origin. Consider this as the origin. It goes along x-axis. So we'll take this as x-axis. To a point minus 20 meter, 0. This origin O. It travels up to 20 meter, 0. So, and then returns along the same line to the point minus 20 meter, 0. So the question is, find out the distance and displacement of the particle during the trip. So the distance is the sum of the lengths covered by the particle. That means it has covered 20 meters towards positive x-axis, that is plus 20 meters. It has covered again 20 meters. While calculating distance, forget all plus and minus symbols. So it is again traveling 20 meters. So distance is sum of these three. So it will be 60 meters. So how to calculate displacement? So displacement can be calculated from sign convention. So it has gone 20 meters in the x-axis. We consider it to be plus 20 meters. It has come back to origin again. So this is minus 20 meters. Again it has come 20 meters towards left. Again it is minus 20 meters. Now sum of these three will give you displacement. So that is minus 20 meters. Or else you can go with vector notation. That is 20 I cap plus of minus 20 I cap plus of minus 20 I cap. So it is minus 20 I cap. So by writing displacement, you have to mention direction. That is towards left. If you are writing in a vector notation, no need to write the direction, because the vector notation will give you the direction, that is towards left. Okay, this is the first problem which we have seen. We will see the next problem. Let us look at the second problem. A wheel of radius r is placed on ground and its contact point is P. If wheel starts rolling without slipping and completes half revolution, find the displacement and distance of P. We have to find displacement and distance of this point P. You have to consider that point P as a particle now. So as I have said, when it covers half a revolution, this point P travels in this way and it goes and reaches to the point here. I will show here. This is point P. Now it is moving to here. So here this point P will be. So this will be radius. So as the displacement is the shortest path between shortest path length between 2 points, the displacement will be the diameter of this wheel. So solution displacement is r plus r. R plus r, that is 2r units. As I said, displacement is a vector quantity. You have to mention direction also. Without direction, there is no meaning of displacement. Direction is towards up. Now we have to find distance. Also ask us to find distance. Distance is this path. That is initially the point is here. If we travel like this and it moves to here, so this is the distance. The length of this half of the circumference is the distance. The distance is 2 pi r, that is circumference is 2 pi r by 2, that is pi r units. So there is no need to denote direction here as it is a distance. So I hope you are clear with this problem, and keep watching our videos, and we will try our best to give you the knowledge. So thank you so much.